All right, everyone, we'll go ahead and get started here. Okay, so welcome to the Casper Association's first workshop as part of the Ready Player Casper Hackathon. In this workshop, we'll be connecting a simple tic-tac-toe game to the Casper blockchain. The concept of this game consists of a given player playing tic-tac-toe against a function that makes random moves during its turn, and the player's score increases by 1 per successive win until they lose. If a player is beaten by the computer, the player's score will return to 0. When a player reaches a new high score, they may publish it to the Casper blockchain, where it will be stored in our deployed smart contracts dictionary. For this project, we'll be creating a Node.js backend to send deployments and writing front-end logic to utilize the Casper signer for signing transactions. We'll go over the methods used to communicate with the Casper network using JavaScript on both the front end and the back end. We'll go over the smart contract used for storing the high score of each account. Then we will compile the contract and deploy it using the Rust Casper client. To follow along with this project, you'll need a basic understanding of the bash command line, as well as some experience with JavaScript. If you aren't able to fully follow along, this workshop will be recorded and published to Casper's YouTube channel for you to watch later. As I mentioned in the Discord server, you will need Node.js, Git, Rust, CMake, Cargo Casper, and the Casper client installed on your system. You will also need the Casper signer as an extension in a Chromium-based browser. So let's go ahead and get started. First, I'm going to show you the project here, what we'll be building today. So it's a basic tic-tac-toe game. It doesn't look too pretty, but doesn't need to. It's just a proof of concept here. So the idea is you play tic-tac-toe and your score increases. And when you reach a new high score, you can connect to the signer. And publish your score. So we have our new score here. We can sign this. We'll see that we get a callback here with the deploy hash, and we can pull this up and take a look at it. And then there's callbacks for success and fail as well. So once it fails or succeeds, it'll show right here as well. The high score gets updated when you have a new high score. If you don't have a new high score, it won't let you publish, and it won't update on chain either. That's basically the whole concept. It's just connecting with the Casper signer, pulling the high score from the contract, updating the new high score to the contract, and things like that. So we'll go ahead and get started with the project here. So to install the project, you want to open a terminal window on Mac OS or Linux. If you're on Windows, you want to open the command prompt. First, you want to ensure you have Node.js by running node-v. You should see a version number there. Once you've done that, go to your preferred working directory. I'm going to be working from the home directory here. Then you will go about installing the project. You're going to clone this Git repository. Okay, once we've done that, and cd into our new directory, and we'll go ahead and install the required dependencies with npm install. One second here. Okay. Okay, now that we've done that, so let's we'll go over here and we'll begin by generating our keys. So we'll do Casper client keygen contracts, and this will generate keys for our new account. So now we'll want to import these keys into the Casper signer. Go over here. Import our new account. We'll head on over to the keys directory and make sure this is right. Okay, and you'll want to import the secret key from that keys directory. We'll name this workshop. Now we will want to fund our account. So we'll go over to testnet.cspr.live. And from here, we'll go to tools and then faucet. So it looks like I'm already connected here, or wait, I don't believe that. Need to connect to this account. So you'll go into the Casper Signer and click up here to connect to cspr.live. Once you do that, just click I'm not a robot and request tokens. Now this will take just a couple minutes and we should get a deploy hash that pops up down at the bottom.
Are you creating those account, like that account right there, as like a key for the game contract itself, or are you just creating that to like show a walkthrough of like what the workflow would look like? Like I'm gonna make a key for yourself.
Yeah, so this is just creating an account for yourself. We're going to use this account to deploy the contract, but there's nothing special about this account. It could deploy other contracts as well.
And like, could we use our like testnet account that we already have, or?
Yes, you certainly could. Yes.
Okay. Okay.
Yeah. Just make sure to place your secret key into that contract/keys directory.
Okay. Which needs to be in the folder of that like project. Like
it actually does not. No. For this workshop, we're going to be referencing that. It'll just be easier, so you don't have to alter the method.
Yeah.
You use. But yeah, it could support anyway.
You could just go like into if your keys are actually stored like in another location in Key Manager or whatever, or Casper Node, then you can just go there.
Yeah, as long as you can reference your secret key to do the deployment, then yes.
Okay, cool. Thank you.
For sure. And now we'll go over here. So let's see. So we funded our account. Now let's go ahead and review the contract here. So let me pull this up. I'm gonna open this up and take a look at it. Go over it real quick. Okay, so let's first take a look at this call function here. This function is called when the contract is deployed. What we have written here creates an entry point called add high score with a parameter of type uint512. It then instantiates a new contract and stores it on chain under the key high score contract. A uref is created and stored as well, but we won't be using it. That is right here. This uref is used to listen for events of which our contract emits none. Next, we'll look at the add high score function. So this function represents a public entry point to our contract that we can call from any client. The first line, defining the dictionary uref object, creates a dictionary in our contract named high score dictionary, or references it if it already exists. Next, the score constant is defined and set to the argument score that we will pass into the entry point. Then a conditional statement is made. If the score is greater than the score that currently exists under the user's account hash, we'll set the passed in score to the high score value in the new dictionary, or rather just in the dictionary, not the new dictionary. So in this instance, we'll use the and get caller function here to get the account hash of the account that made the call, and we'll store the high score under that hash. So we'll be using the account hash as the key in this dictionary, and we'll be able to use that account hash to get the score of a person. It's like a key value pair. Okay, so now that we've gone over that, it's a pretty simple contract. So we'll go over and we'll actually go about compiling it. So, okay, so once we're in this same folder, the same root folder of our project, we're going to cd into contract. And then we're going to run make prepare. And then make build contract. And this is what you will need CMake for.
So is there a limit to the amount of variables you can put in the contract?
You know, I don't know actually. I know that on Ethereum they have something like that, like where the stack goes too deep. That's something that actually, if you wouldn't mind to go ahead and DM me that question, And I'll pass that on to one of our engineers and get that answer for you. No problem.
Sure. I'm just thinking of like total games, total wins, total losses, high score, that kind of thing. It's probably not going to reach the limit, but it would be good to know.
Yeah, as far as I'm aware, there is no limit. I can't say that for sure, but I don't think you'll run into the limit. It says we have an error here, but that's actually no problem. That's just in this WASM strip here. That's not something we need to worry about. So the file will then be created in target WASM 32 unknown release high score.wasm, but we'll go over that in a second. So while still in the contract folder, you're going to want to enter this following command here. It's a bit of a long one, but we'll get to it here. I'll put deploy, do this slash, so we can go on to the next line.
I entered this so many times yesterday going through the force module. I don't know about anyone else, but yeah, I entered that so many times.
Yeah, that's true. Yeah. There's certainly a lot you can do with it. Going back and forth.
Same here.
So chain name, we're going to do Casper test. Casper test is the test net, and just Casper is the main net. And then we'll define our node address. For this one, I recommend using the same node address that I'm using. I know that it works properly, it's up to date, all that, but you can use any node on the live peers list, which I can direct you guys to later as part of the resources. But
yeah, if it's possible, can you add the documentation link?
Here it seems we got some feedback here. What did you say there?
So would you recommend creating a list to cycle through node addresses to have a verifiable or sort of a fallback in case a node isn't active or updated or something?
Yes, actually, yes. So I would recommend that. I actually ran into this problem when helping someone out build a Casper app through the JavaScript SDK a while back. And yes, so that is currently the best way to go about it, is to just poll for new ones and have a list of them. For example, for one to fall back on.
I wasn't able to get a response, or it was blocking the response from a CORS policy violation. And yeah.
Interesting. So nodes do have these CORS policy requirements. If you run them from a server, for example, and not from the front end, then it should work. If you run a lot of these commands from the front end, a lot of these queries to the nodes, then a lot of times the CORS policy rejects it.
Right, and I guess that explains why a proxy fixed it.
Yeah, definitely so. Okay, and then right here we're referencing our secret key that we had. Oh, whoops! I accidentally entered that, but that's okay. Okay, session path. This is our WASM file that was just created and is in that folder that I had just mentioned. Okay, and then our payment amount, and this is denominated in motes, which are there's 1 billion motes per CSPR. So we're going to aim high with this. We're going to do 30 billion motes, which is 30 CSPR. I know that this contract costs, I think, 23 CSPR to deploy. But one thing I should say, if you're not familiar with this already, Casper, as of now, does not pay you back for the gas you don't use. So the gas that you pay, this 30 CSPR will be eaten, but that is okay. So it should work here. Okay, great. So
is there a function to query the network for what the current gas price is, so that you can calculate in a deploy the exact amount that you should reserve to do the deploy?
Yes, there is. I don't know that offhand. Like, I don't know the function offhand. I don't know how to go about it. I know that does exist. And if you, that's one thing also, if you could send me a message, I can send you the documentation or get you in touch with someone that knows that, or ask them and get you the answer. Right now, the gas price is fixed at 1 CSPR. So that is a thing to note. But yes, there is a function in that regard.
Okay, thank you.
Yeah, I can get that to you. So we'll go ahead and take this deploy hash, and we'll go over to the test net here and just look this up, and we can watch and wait till this succeeds. There we go. Okay. Now we'll head back over here. Go ahead and clear our screen, make it a bit prettier. And now we'll run this command to get the global state root hash, which we will need to query the contract to get the contract address. Okay, now we have the state root hash. And now we're also going to need the public key hex of our account, which we can get from cspr.live, or we can just go in here and cat this out here. All right. And then from there, we can query the state of our contract. So now we'll do put in our node address. We'll just go ahead and put this in here. You could also reference this as a bash variable. Put that in there. State root hash. Could do the same way if you wanted to parse this JSON out. You could do it in a bash variable as well. That should give us our account, which under our account, we can see that we've deployed the high score contract and we have a contract hash for it. So we're going to take this right now and make note of it. We'll just, in fact, I'll tell you what we'll do. Put it right here. Beautiful. Okay. Okay, now we're going to go ahead and open up server.js and we're going to edit it. So this is the Node.js server. Open that. And as you can see, it's going to be blank here. So let's see. I need to just give me one moment here. I need to open up my other one. Sorry, 1 second here. I want to make sure that that I get it all right. So I want to pull up my completed file. Awesome. Okay, so this is the completed file here. This is what we're going to be building out. I'm going to go ahead and pull this off into another window so we can just build it together. Okay. All right, there we are. So okay, so we have a blank file here. So 1 second. All right. So now that we've opened up server.js, which is in the root of our project directory, we can begin by importing and setting up client and contract instances. So we'll go ahead and start by importing Express, which is a node package that's going to allow us to run a server pretty easily. Here, where we're going to define our CORS middleware. Okay, and then now we are going to import all of the constants that we need from the Casper.js SDK. So we're going to need runtime args, all these classes, CL value builder, Contracts. CL public key.
So if you wanted to, in the Casper Signer and Adapt tutorial, they're using Vite or Vite, V-I-T-E, as the server. If you wanted to, would you be able to put the app into production and just let the user's browser have the mini server running to be able to query the contract?
Yeah, so I'm actually not very familiar with Vite in and of itself. I know that on the front end, the way it currently works, the Casper JS SDK does work on the front end. I don't know if this Vite sort of acts as like some kind of back end server for the front end in some type of way. I'm not exactly sure.
Yeah, it does. It does, but I'm not sure if it's only for development or if it can be used in production as well.
I see.
It
Yeah,
seems like a very hack way to do it in production.
Yeah, I'm not sure. Does seem a bit hacky. You can use the entirety of the Casper JS SDK on the front end. The only problem is, of course, you run into CORS policy problems when you're making deploys and things like that. You're not
Yeah,
able to.
and it does have a solution for that. I implemented it. It's using a proxy, but I just don't know if it's going to be stable if it's built.
Yeah, I know what you mean. I can imagine that it would be stable. That if you're doing it that way, I can imagine that everything should go fine.
If it is, then that would be great because it would remove the need for a backend on smaller apps, at least.
I wouldn't see why not that you couldn't do it that way.
Okay, cool.
Okay, next we'll define our Express app and our port. Port 3000, but you can do any port. Now we'll instantiate the client. So type new Casper client, and we'll put in our node address, same as earlier. I know somewhere along the way I'm going to type one letter wrong. It's not going to compile, but I'll be able to fix it up. I'm just sure we'll have to go through it at the end there. Okay, now we'll instantiate a contract instance. Pass in our client for that. Now we will set the contract hash that we just received. Put that over here, but yours will obviously be different. And there are methods to pull this contract hash from the account. I have yet to build those. I will probably do that for the next workshop, but there'll be more details on that on Friday. So, okay, now we will we'll use our middleware. So we'll app.use. So this, we're defining our static directory where we'll be pulling our CSS and front-end JavaScript.
Was that hash from your account or is that from the contract?
So that's the contract hash in and of itself.
Okay, yeah, that was created after the deploy. So you can find that like in the deploy details or whatever.
Right, that's correct. Yeah, and you can also find that in the named keys in your account if you were to go to cspr.live, for example.
Yeah. Okay. Yeah. Perfect. Thank you.
For sure. We'll use our CORS middleware. Express.json, so we can pull in some JSON from a post request. Now we will listen. 3000 here. So we'll just log this out here. Will be for our home page here, our index page. If you're not familiar with Express, rec and res here are the common variable names. They represent the request and the result of the HTTP request. Here we'll just send our HTML file. Now we'll go on to our send deploy endpoint. So this will be a post endpoint that receives a signed JSON deploy from the Casper signer. And that'll be from the front end, which we'll go over in the contract interaction, the next file that we go over. So this will be send deploy. This can of course be named anything. You'll be calling this from the front end, so any, whatever you want to name it, as long as you do it the same on the front end, will work the same. Sign JSON is equal to the post body. And then this is where we'll be using deploy util, one of the classes in the Casper JS SDK, and we'll get a deploy object from the JSON string. Or rather, it's not a JSON string. It's actual JSON object in JavaScript, but nonetheless. I'll unwrap, which will pull it together to a deploy object. Sign deploy send. We'll do this to our same node address. You can actually also do this with a client put deploy, I believe. That's something I'd have to look into, but I'm pretty sure you can do that the same way. And once it gets a response, we'll send that to the front end. And so this will just be a success response, and it'll include our deploy hash as well. Errors. Log this out for now. You can, of course, do whatever you want to handle the errors here. Right, now we'll go on to our get deploy endpoint. Rec and res. And then we'll get the hash, which we'll push from the front end. This is a get request, we're just getting the get parameter. And then we'll perform client.get deploy. Pass in the hash. And when it's complete, send back the execution results. This is probably bad practice in terms of you should probably want to check that this array exists, because it'll throw an error. But that's obviously something you could do while building your own project. Another thing you could do here is have this be like a 400 status code or something. The way I built this, I didn't care much about it, because it's more of a proof of concept of the Casper JS SDK in and of itself. But there's many things here that could be improved. Okay, now we'll go on to our get high score. endpoint. And so this will allow us to query the contract dictionary to get the high score of a user. This is actually how I'd written this. This is incorrect. This should be account, but it's the same thing. In fact, we can rename it account there. We'll keep it hash just so it's the same in the front end. We want to do contract.query contract dictionary. And so we're going to call our high score dictionary the named key, and that's the same as in here. If you'll see, it's that same key there. And then now we need to build a public key. So that's a CL public key from our hex key, which is to account hash string. And then what we're going to do here is we're going to substring by 13 characters. And again, you probably want to do this with regex or something. But so what happens is the account hash string that's returned is preceded by the words account hash, which happen to be 13 characters, this right here. So that's why we strip that off, because that's how it stores it on the contract. So substring. Okay, that's right. Okay, yeah. And then once we get the high score, we send it back to the front end. And this comes back as a hex integer, but you can just transfer that over, parse it over to an integer on the front end. Okay, and that's the get high score endpoint. And that'll actually be the end of our server.js file. So now we will go in and we'll open we'll open the contract interaction file, which is front-end JavaScript. So that's the finished version here. There we are. All right. So first, let's define our variables once again. I actually don't know if I use anymore, but we'll go ahead and same node address. Contract again here too. Just keep a global reference here. Also probably not best practice. This get deploy interval here. This is going to represent a set interval function in JavaScript. We're going to be calling the get deploy multiple times. but we'll go over that here soon. The signer is connected. And we will change the button text. This is how you send a connection request right here. Once you run this function, the Casper signer will pop up in a new tab and ask you to connect. Move on to our create deploy function. So this is where we're going to be building the deploy to actually send to update the high score on chain. So we'll first ask if the active key is equal to null. We know they're either locked or not signed in.
So I'm coming from using Web3 and integrating MetaMask into apps. Would it be accurate to say create deploy would also be a transaction builder?
Yes, that's right. So yes, so on Ethereum and in Web3 in that way, it's common to call a deployment. Like you only say the word deployment, right? If you're like deploying a contract. In Casper, we use that word pretty universally. So a deploy is any transaction. Effectively, you're deploying a transaction.
Okay, thank you.
Yeah, that's a good question. I'm glad you asked that, so we could clarify that. We'll return if this is the case. Say if the score is equal to 0, 0. Now, if the high score is not equal to null, and the score okay, now we'll define our arguments. And this is an instance of runtime args here. Args, and we'll create this from a map. Score key. There's a CL value builder. U512. And if you have a different integer type, then there's other ones for this, obviously also unsigned, signed, the whole 9. So there's our arguments. And now we'll get our public key. We're building a CL public key object from which is just our hex public key as a string. And then we will go and we'll set our contract hash. So now do the results of the creation of the deployment is equal to contract.call entry point. So you remember we had that high score entry point, that add high score. Call that here. That's in our arguments. That's the public key. Chain name, which in this case is Casper test. I have a function built here, which we'll go over at the end. It's simple, but CSVR to notes. And so this is for asymmetric keys, this parameter right here. This is if you're doing it on the back end, for example, or you have a asymmetric key object, which is public key and private key. You can call this with this as well, but we're going to be signing with the Casper signer, so it's no big deal. And then the TTL, time to live, this doesn't matter as much. There's a default value, which is very similar to this. I think that just means the amount of time that I'm actually not 100% familiar with this, but I'm pretty sure it's just the amount of time before the deployment would get rejected, for example. That's something that Jan actually knows more about. But. Okay, so now we'll turn our deploy into JSON. We'll use the deploy util, Casper JS SDK, and deploy to JSON. Okay. Now we will initiate the signer request. We'll do signer.sign, deploy JSON. Key. Promise here, so we'll send deploy success, which we're going to define this function later. Send deploy. Next, we're going to do this right now on the send deploy function with the sign deploy JSON parameter. And so we're using Axios here. So this is the front end. We have the CDN set up in index.html. You could do this on the back end the same way, or you could use any other method of making HTTP requests. We'll call the send deploy endpoint that we made in server.js. Pass in our sign deploy JSON. And then we need headers. We need to change the content type to application JSON. Looks good. This is our deploy hash that we're going to get back from the server.js. Paste in this function here, which is not specific to this. This is just to update the status label on the home page. And then we're going to do initiate that deploy procedure, which we're also going to define. Now, so this animate status by appending that I'm putting on here. This is also just the status label. This is all defined in index.js, which you're welcome to go around and mess with as well. We're not going to be going over it today just because it's not related to the Casper signer at all. It's all just front end stuff. Then we're going to call, do this here. I'll just paste it in and then go over it. So get deploy. Did we do that? No, we haven't. So we're going to do this next. So we're going to call get deploy once to start, and then we're going to set an interval to do it over and over. And we're going to need to poll for the execution of the contract on chain. So when a validator executes it and deploys it, and it's come back successful, then we'll break out of this. Same way, if it fails, we'll break out of it, but we'll need to keep polling, and you can change the interval. Right now we have 5 seconds but we'll go ahead and define our same thing. We're going to use Axios to talk to our server. This is get parameters right here. The hash as the deploy hash. Now we need our headers. Also content. Okay, so this is coming back from here. So this is our execution results. It's coming back from get deploy. And as you can see, I just noted that down here. So first we're going to check if response.data.length is equal to 0. If there's no return data yet, that means it hasn't been executed. There's no execution results. So we just return out of this and we wait to get pulled again. So what this checks is if execution results has its own property result, like if it has a key directly under it called result, then it has the result and we're ready to continue. If it doesn't, which is what we're asking for here with the not, then we're going to say it doesn't have the result yet. We'll return out. Now we're going to say if the result success, then we know it succeeded. And we will we'll stop the animation, and this is for our status bar again. Don't worry about that. And get high score, which we haven't gotten to talk about yet. Okay, so else if the result has own property failure. We will stop the execution. And for right now, we'll just say failed. Okay. And then else, I'm actually not sure if this is possible to happen. So we'll say you might have to, you would maybe have to test over and over until you got a strange incidence where it's not success or failure, which it's probably not even possible. But okay, so now we'll go ahead and we'll clear our interval because we're done here. We've gotten the stuff, gotten the success or failure. So we'll clear our interval. And this is global, so you can just make a reference to this right here. Stop animation and then clear interval the same way. Okay, and that does it for the get deploy function. I'll move on to get high score. Passing in the public key as a parameter. We'll use Axios again to make a request to our get high score endpoint.
So last night I was looking at this, the U64, U32, U512 numbers, and I found a chart for what the equivalent numbers are in decimal, but 512 was off the chart. It wasn't even on the list. So is that like unlimited or?
No, so it's not unlimited. It's 512 bytes long. If I'm thinking about that correctly, not bits but bytes. And so I mean, yeah, it is ridiculously long.
Okay, so in UTF 8 characters, it's like 8 bytes per character. So you'd be able to have 512 divided by 8 characters.
Yeah, well, so I guess if it's 512 bytes long, then you'd be able to have 512 characters. But there's people know more about that than me. I'm not exactly sure, what the number is. It's like, but that might be, I guess that might be binary as well. So it could be.
I might be confusing bytes with bits.
I may be
I
as
don't
well.
know.
But I mean, there's certainly resources for that online, and this follows the same convention that the rest of them do.
Yeah, I know on Ethereum they use bits for gas in relation to hex characters with putting hex data in a transaction. So
Gotcha. Yeah, that may be the case. Yeah. I think they're, I mean, I know that they're the same data types. Like U512 is going to be the same in here that it is elsewhere. U256 the same way. So if like you could look that up for any instance and it'll still apply here in Casper.
okay, thank you.
For sure. This will provide our public key. We'll use that to get the high score. And response. And so this is us getting the response from the server, from our server. Set high score. This is also in the front end stuff right here. So that's just setting the high score on the page. And this function also sets the global high score now that I think about it. Okay, and then that is it for the get high score function on the front end. And from there, okay, well, I'm going to go ahead and just paste in this button press thing. We can go over it briefly. This is just for the button on this page here. We ask if the signer is connected. If it is the active key null? If it is null, we try and get the active public key. Otherwise, we alert with an error. And this alerts here if our signer's locked. So if I were to go over here, as far as I'm aware right now in the Casper.js SDK, there is no is unlocked or is locked feature. There's callbacks, which we'll go over in a second, event listeners. But from right now, oh, okay, well, looks like we're doing fine. I've actually run into problems with this before where it just throws an error and you have to, it pops up right here, and it'll say, please unlock your vault to continue.
Yeah, I get unrecognized promise or something.
You said unrecognized promise? Is that what you said?
Yeah,
there?
but I'm using React, so that might only be for React.
I see. I'm not sure the exact case on that, but I'm sure it's application specific. But yeah, I'm not exactly sure why that is, but be happy to help you. If you did run into problems, let me know on Discord and then help you. But anyway, so we'll continue here. And then so we'll set the active key, set the button context. Otherwise, if it is connected and the active key is not null, then we'll create the deploy. Otherwise, send sign. This should actually be changed because I had it with send sign, but it's actually this right here. And then we'll do our event listeners. So the signer, fires event listeners when the state changes, which is really useful. So do add event listener. And it returns information from assignment to it. In fact, I will just go ahead and paste the rest of these. We've gone through one and we'll just walk through them. So, so yeah, you have signer locked, unlocked, active key change, connected, and disconnected. And when these event listeners fire, they fire with this message variable. And you can get active key. You can get lots of other information as well. I don't know it right off the top of my hand, but I do know that there's lots more information that you can get from the signer from here. So all sorts of cool stuff there. And then, as you can see, there's these functions recently connected. That's just this right here. It just performs a quick update on the active key. And then our last two functions, set active key label, just basic front end, and then Casper emotes, which we looked at earlier right here. So that actually should do it for the for both these files here, and we should be able to go ahead and test things out. All right, so as long as everything that I wrote everything properly, which I probably didn't, we'll probably run into an error of sorts, but we'll be able to fix it up real quick. So make sure you're in the root of your project, and we'll go ahead and run node server.js compiled. So I'm on 3500 here because I was running another instance to show it from the start, but I'll go to 3000 here. And okay, yeah. So we don't have our styling loading up. So let's see. There's what I did wrong there. Does anyone else happen to have it up by any chance? I don't know if you've been following along fully, but if anyone else has it up, feel free to let me know what's happening. Let's see. Actually, knew something would happen. So I'm not doing that. Well, let's see if the JavaScript still works. Oh yeah. Well, so. Can't find Casper JS. Huh. Well, I've got to say, I'm not totally sure what I did wrong. Yeah, I thought this may happen, when you rewrite this whole project. But what it should look like, this right here. And I assure you that all the code is the same. Not sure why it didn't work as is. Also, this repository, like the completed one, will be available along with the template. So the template also will include this workshop document, which I'll pull up here. So this is like the whole explainer here. This explains everything, and you'll be able to go through and try it yourself and do things like that. So like I said, the template and the completed version are both available in the repository. This is the completed version. It's the same code we just wrote. For whatever reason, mine isn't working. I'm sure I did something wrong somewhere, but this one does work right off the bat. You can just clone it, load it up, and get it to work. So we can go ahead and test out the functions that we just made. Obviously, it's a different instance, but operates the same. So you can see our high scores going up right now. We don't have a connected account. If I see it, please unlock the signer to read the key. So unlock the signer, and we have account connected. High score is not a number because we don't have one set. So we have a score of 3 right here. You can publish. You'll see our score gets brought in there. Let me see if I can. So yeah, payment is 1 billion motes. We defined that earlier with the Casper emotes, and we put 1 in there. So we'll click sign. Now we have this. So this is polling every 5 seconds. We can see every 5 seconds it says no return data yet. But we can view this on cspr.live. It says pending here. But what's cool is this will effectively act as a callback. We're really just polling, and then this will turn to a success or failure whenever it executes, which will wait 30 seconds or so until that happens. Should update the high score as well.
For people that like yourself and others that like work at Casper, work with Casper, is that the most common like stack of web development tools to use?
Yes. So
Or-
like, in terms of the Casper JS SDK, yeah. So that is the #1 development tool for web development with Casper, if that's what you're asking.
Yeah, but I guess I meant like because like you didn't use React in this case.
That's right. Yes. Okay. So yeah. So React actually is the most common. Is the most common way to think about it in Casper. So I mean, I have a bit of background in web development, but I mainly did HTML, CSS, and JavaScript, just raw. So when I created this tutorial, I went through that. But all the functions operate the same way. And at the end of this tutorial, I'm going to provide you with resources. The best way to really learn about it is to go through the classes in the Casper JS SDK. It's very well written, well documented by Jan, who I don't know if he's still in here. Yes, it looks like he is. And he'll be able to answer some questions too. Here at the end, if there's any questions that I'm not able to answer, then he certainly will. So you can see we got this deployment successful here, and we can go over here and verify that that's the case, and it did succeed. So it says our cost is 0.09 CSPR, but if we were to go back, you'd see that it did take the entire 1 CSPR. So yeah, so let me see here. I will, where did I put my, okay, yeah, so over here. Okay, so conclusion. Actually, before we conclude, I want to go ahead and give an example. Let's go back into the contract interaction. We'll do like 0.0001. Right. Or wait, actually, now that I think about it, that is the wrong instance. I'm gonna have to do it over here on my other screen because we're showing the one that is working. So I've done the same thing over on my other screen, just put 5 zeros ahead of that, right here. And then if we were to go back, let me make sure that I've restarted the server. Here we are. Refresh that. So now if we were to get so we have to be connected, one. And then so you'll see our high score is 3. So that calls from the dictionary. So now I got to win 4 for us to be able to do this. All right. So publish, and you'll see we're only doing 1,000 motes, sign, and this will do this here. And then we'll see that it will fail. And that should take anywhere from 30 seconds to a minute. But while we're waiting for this, here, did you have a question?
I did. How much does it cost per deploy for deploying your new high score?
It's quite cheap. Only I think it's 0.09 CSPR. I'll actually check that.
So less than a penny.
Yes, yep, right here. So 0.09. So effectively 0.1, which is yeah, 0.6 of a cent.
Okay.
Quite cheap.
So you wouldn't really be wanting to do this. I mean, I suppose players could set it to have it updating constantly after every game, but I guess you would want to do it per session, like once per session,
Yeah, you
or
would
even.
ideally, yeah, want to do it once per session. Or like let's say so the way it's written, if I were to reset and continue playing, even with my score at 4, and I lost or what, well, can't seem to lose. But if I were to lose, for example, then like you would think that maybe you could go and update your high score after you lose, like now that which honestly might be the best way to go about it. I have it right now to where you can just publish it at any given time. But yeah,
Right.
you ideally want to do it once per session.
So I'm thinking in the context of a MMO RPG where it's an open world game, it's online, every single detail has to be recorded.
Mhm.
And I mean, you can have the option of playing single player if you wanted and only uploading what you want, but in a multiplayer game, it has to record everything to prevent cheating.
Right.
Um, so I can see that getting expensive.
Yes, so I mean, it certainly could. I mean, so you have that same problem, that you run into with scalability on the blockchain, that you're going to run into anywhere. We do obviously implement tons of methods to make gas cheap and make it very efficient. But so I mean, the idea with that, I guess, would be to store whatever you can off chain, and then like player data, like important data. That you would need to store on chain. There are ways that you can cut down on gas by I mean, that's a bit more complicated. You need to do a bit of research to get your functions down to use less gas. But all in all, as long as you're only uploading a small amount of data, it's quite cheap to do.
Right. Okay.
Gotcha. So I'll go ahead and conclude here. So this concludes workshop 1 of Ready Player Casper. We'll be hosting another workshop next Wednesday at 12 p.m. EDT also with more info Friday of this week. To learn more about the Casper JS SDK, I personally recommend reading through the classes it provides. Okay, so I have this link here. I'm going to go ahead, actually I have multiple links. I'm going to put them in the Discord in the workshop section. So Casper JS. So there's the classes for the Casper JS SDK. I've just sent that over. Now I'm going to send the template and the completed version of this workshop if you'd like to try it yourself. So there's it. Okay, I've sent those over. I also recommend looking over these 2 repositories that I'm going to provide right here. They're demos that you can install, test, and change to show the capabilities of the Casper Signer. So these have been written by some members at Casper Labs, and they're quite good demos. They'll help you get started with this in a similar way that this workshop will be able to do. Okay, and now I'd like to go ahead and answer some questions. If you guys have any questions, and then Jan is also in here, and he's going to be, well, actually, let me make sure so he is still in here. If there's any questions I can't answer, he will help to answer them. So if you have questions, just go ahead and unmute yourself and ask away. Yeah, I guess we may have gotten all the questions out as we were going. But I personally don't think that's a bad thing. I think that's probably better. But if there are no questions, thank you guys for joining. I hope you learned something, and I hope this was helpful in your development. Please reach out to me on Discord if you have any questions. I'm happy to help. I'll get in the weeds with you, and I'll get you answers. We'll be having another one of these next Wednesday. More info on Friday. It'll be more complex. We'll be doing more. I'd like to use another framework or another like programming language to do this. So, you know, I know we have other SDKs for front end clients and things like that. So, so I'm gonna get all that together, and I'll give you more information on Friday. But otherwise, thank you very much for joining. If you have any questions, you can still ask them. Otherwise, we'll go ahead and end here in a couple minutes.
Definitely helpful. Thank you. Yeah, that was good.
Good. Glad to hear that. That's awesome. All right, I'm going to go ahead and end the call here. Thank you guys so much for joining.